All right, guys, welcome back. We are actually going to be finalizing our unit on nuclear chemistry this week. There's just one more concept we need to deep dive into, and that is what we call a nuclear half-life. And the definition of a nuclear half-life is the time required for a radioactive nuclei to reduce by half of the original amount. So let me give you guys some visuals of what this actually means. So for my visual friends, I do have a graph here. So a half-life is pretty much how much time does it take to go from like 100 to 50. So in this case, my half-life, let's say I start with 100 grams of a sample. And then how much time did it take me to get down to 50? And let's say we have time in days. So the half-life of my sample would be 2 days. In that time frame, half of my original amount was lost in the reaction. Now, when I say it's lost, it doesn't disappear because we know that nothing can be created or destroyed. It just then turns into its accompanying product. So let's say it went through alpha or beta decay. So this 50 grams, let's say we have, and let me pull up an example from last week. Let's say we have carbon 14 undergoing beta decay. And this is an example, guys. I don't think this is the actual half-life of carbon. Let's say I start with 100 grams of it. After 2 days, I only have 50 grams of this guy. The rest of it is then converted into product. So that is the whole concept of nuclear half-life. It's kind of a simple concept that we're dealing with this week. So with simple concepts comes a bunch of example problems. And I definitely wanted to just go ahead and show you a list of a couple of radioactive elements and their accompanying half-lives. As you can see, a lot of different time frames here. So some take forever to decay, and others can decay in about 1.8 milliseconds. So there is a multitude of different half-lives depending on what type of element you're dealing with. That being said, I am going to do 4 examples. They are kind of quick, but they do get tricky. You got to make sure that you're reading the question and really, really internalizing what the question is asking, or you might get tricked. So don't get tricked. And for the sake of not getting tricked, I'm going to give you guys 4 examples, and we're going to practice this all week. All right, so let's start here. And again, I wanted to give you another visual. So when I talk about nuclear half-life, that is how much of this sample is halved. Like if I start with 100 grams, how much time does it take until I get to 50 grams? And in this case, I have alpha decay as we see that helium, and we see that new element of, is that radon? No, it starts as radon. No, it ends as radon and it begins as radium. I always get those two confused for some reason, and this should definitely be a lowercase. Okay. So let's look at our first example problem, and I'm going to show you exactly how to organize these. So the first thing I'm going to do is like read through it and just write down the information that I know. So this is radon, and it has a half-life of 4 days. So that means in 4 days, I'm going to have half of the original sample that I started with. This is asking how many half-lives, and I'm going to abbreviate it the entire time as just HL, so you guys are aware of what that means, before only 2.5 grams is remaining from an 80-gram sample. So this is asking how many half-lives went by before I only had 2.5 grams from my original 80. So let's write down the information. And sorry about my dogs, guys. So the half-life is 4 days. I know that I start, there's my other dog, with 80 grams. And I end with 2.5 grams. But how many half-lives did it take me? Let me let him out real quick to get going to that 2.5 grams. So the way I like to do these is kind of just writing it like a chart. So I start with 80 grams of my sample. After 4 days and 1 half-life, I know this is going to be halved. Half of 80 is 40. Not at 2.5 yet. So Let's take another 4 days. I know that now this amount is going to be halved. Half of 40 is 20. There's my second half-life. Not at 2.5 yet. I'm going to keep going. Here's another half-life. Another 4 days pass. Half of 20 is 10. And there's 3 half-lives. Still not at my goal. Let's go another 4 days. Half of 10 is going to be 5. So there's 4 half-lives. Let's go another 4 days. And half of 5 is going to give me my end amount, which is 2.5 grams. And my answer, what the question is actually asking me, it's not asking me for how many days have passed. What I'm going to report is that 5 half-lives have passed, because that is exactly what the question is asking me. So it's really, really, really good and a strong tool to go ahead and write this on the side of your paper. All right, let's see another way a half-life question can be asked. So in this case, it says you start with 900 grams of iodine 131. The half-life of iodine 131 is 10 days. So here is more important information. So I know the half-life is 10 days. How much iodine is left after 70 days? So I know I start with 900 grams. I don't know how much I end with. That's what I have to find. And I know that the time is 70 days. So the first thing I'm going to do is find out how many half-lives is that. So I know one half-life is 10 days. So I know clearly 70 divided by 10 is going to be a total of 7 half-lives. But that is not the answer to my question. I want to know how much am I going to end with after those 7 half-lives. Now you guys can write all the days and stuff, but I'm just going to run through this one quick. And I'm actually going to grab my calculator too, because that helps. You're pretty much just going to half this. And you can just keep writing divided by 2, but I strongly, strongly encourage writing it down as you go so you don't get messed up along the way. Just halving this sample 7 times. So here's one half-life. I know 900 divided by 2. I'm going to have 450. Let's go to my second half-life. 450 divided by 2. 225. Let's go to a third half-life. And again, I'm going to keep going. I have 112.5. 4 half-lives. I'm going to have 56.25. Still didn't get to 7 yet. At my 5th half-life, I'm only going to have my starting amount at 28, and I'm going to just round to 28.1. Here's my 6th half-life. Dividing that by 2, I have 14.1. And then I'm sorry I kind of ran out of space on my paper. But if I divide this by 2, I'm at my 7th half-life, and I end up with about 7.0 grams of my sample. And that is what my question was asking. What's the end amount that I have of my iodine 131? The rest of it has been turned into a new element that either underwent alpha or beta decay. All right, 2 more, and then you can try some on your own. So this one says the half-life of palladium 100 is 4 days. After 12 days, the sample has reduced to 3 grams. What was the starting mass? I'm going to write down my key information. So my half-life, I know it takes 4 days. My start, I don't know. I know the end is going to be 3 grams. And I know the whole time that has passed is 12 days. Well, let me find out how many half-lives that is. 12 divided by 4 days. That's 3 half-lives. So I need to just kind of go back. I'm going to start from the end. And I'm going to kind of go up. In the previous examples, I was going down. I'm just going to double this time. Instead of dividing, I'm going to multiply. So I start with 3 grams. 4 days have passed. 1 half-life has passed. This is going to double. So 3 times 2, 6 grams. Let's go with my second half-life. I'm going to double this amount now. So 6 times 2. We have 12 grams. And I know I have to get to that third half-life to find out what the original sample was. So times 2 again. Third half-life. I started with that 24 grams. And that is what I'm going to report. I started with 24 grams of that palladium. All right, last example. You're going to see all these questions all week, so please, please, please make sure you're following this video and you have a strong understanding. If you don't, again, my phone keeps dying whenever I try to take a video. Got to get that checked. Please reach out. All right, last example. I have 100 grams of an isotope with a half-life of 40 hours. How many hours will have elapsed when 12.5 grams remains? So, this question is telling me that my half-life, sorry, that's Blaze, is 40 hours. I know I start with 100 grams, and I end with 12.5 grams. This is asking how many hours. Now, our first question asks us how many half-lives. This time, I do need to incorporate how many half-lives, but I want to know how many hours have passed when my sample decays down to 12.5 grams. So let's start with our starting amount. I start with 100 grams. And when one half-life has passed, I know that 40 hours has passed. And 100 divided by 2 is 50 grams. Sorry. So let's let another 40 hours pass, and that's going to be our second half-life. 50 divided by 2 is 25 grams. Okay, still not at 12.5, but another 40 hours has passed, and I am at half of 25, which is 12.5, and that's what I want to get to. That was 3 half-lives. Now you can either take 3 and multiply it by 40, or you can just add all these up. Either way, you're going to get the same answer. 3 times 40 is 120, or if you add 40 plus 40 plus 40, you're going to get 120 hours. So please, please, please make sure you're paying attention to what the question is asking and that you are giving the number that it is asking for. Now, don't really worry about sig figs. In each of your Google Forms, I'm going to write the directions as to where I want you to round, if I want a whole number, if I want a decimal. It will all be clear in there. And again, watch this video a couple times over if you have to. And if you want to jump on office hours, again, Tuesday, Thursday, I'll be here to help. Good luck, guys.